We've got Craig Theriac, who's the VP of Product Management. Craig, I'm excited to have you back. It's been a little bit, but not too long. So I'm going to pull you up on stage and we'll get this party started, or continued, really.
Hey, Mackenzie, how are you doing?
Good. How are you doing today?
Not bad. Thanks for having me back. It has been a little while, and I have to say I have to agree with the comments in the chat. That was just like a sitcom. I would definitely watch that. Those two are fantastic. So it's a tough act to follow, but hopefully we can keep the conversation going.
Right. Well, I've got faith in you. I got faith in you. So I'm gonna hop off for now, but I'll be joining you for Q&A after you're done, and we'll keep an eye on the chat and comments.
Perfect. Look forward to it. Thanks, Mackenzie. Yeah,
Thank you.
so I'm Craig Theriac, as Mackenzie said. I'm the Vice President of Product Management at Scale Computing. I've been with the company for, 15 years ago is when I first joined. I've seen this through several transitions, probably the most recent of which was back in 2012. We first introduced an HCI product that we call HyperCore. So HyperCore is an on-premises solution for kind of allowing you to run all of your IT applications in a really simplified manner. In fact, when watching Rick earlier, when he talked about the hypervisor shenanigans that are in play right now, I would say we see a lot of customers right now that are looking at that as an opportunity to simplify their IT environment, to make sure that the applications that they have running on premises should be run on premises. And once they've made that decision, put an infrastructure in place that effectively manages itself. And that's what we do really well here at Scale Computing. So use case wise, typically you're going to find this in a smaller mid-sized organization or in a very large distributed enterprise organization, really anywhere where you need little to no IT resources on premises, or you've got some kind of generalist that's in charge of the infrastructure. That's where we play really, really well. So what I'm going to be talking about here today is kind of through the lens of what we do as a solution, but also again, looking at what I'll call the life cycle of infrastructure on premises and things you can do to automate along the way and things you can do to simplify along the way, especially with many of you out there probably facing the hypervisor shenanigans, as Rick put it. So let me first introduce SC Platform, the Scale Computing Platform, and you'll see it's really two pieces. HyperCore, which is the on-premises HCI stack. So it's what we're doing to combine storage, virtualization, compute into a really easy to use solution. And then we have what we call Fleet Manager. And Fleet Manager is a cloud-based orchestration and management tool that kind of gives visibility across your fleet of HyperCore clusters. And those two things work in tandem to give a very easy to use experience for our customers. So as I mentioned, life cycle of the infrastructure. So there's all sorts of opportunity to try to automate along this life cycle, but let me introduce really what it is. It's kind of from the moment you've decided, hey, I'm going to run something on premises today, you have to first deploy it. You've got to configure the hardware, configure the networking. You've got to get your applications up and running on that, whether they're virtual machines, whether they're container-based and kind of Kubernetes flavor. All of that has to be configured initially. And then what I think most people think about when it comes to automation and ease of use is really the day two. It's like, okay, it's up, it's running. How do I monitor it? How do I automate the things that I have to do daily, like failures that are in the environment? How do I deal with updates? All of that. And then eventually you're going to expand it or replace it or kind of make changes to that environment. And that's what I call the day in. So new applications come in, you've got new resources that you need to expand on your existing infrastructure. And really, how do you handle that? So I'll try to talk through each of those individually through the lens of SC Platform. First things first is what I'll call zero touch provisioning. So when you have to go deploy it, one of the best ways you can do is there's a new technology that's really been kind of, I would say, in existence for the last decade, but really taking off here in the last few years, where people are trying to eliminate the need for any IT resources on premises to deal with the installation of this. And I will say with our product with zero touch provisioning, we like to joke that it's really as simple as a baby could do it. And in fact, the product manager on our team who implemented the zero touch had a picture of his baby, which was sitting next to the infrastructure. Admittedly did not touch it, but I will tell you that my son, who at the time was in second grade, I basically had him deploy a cluster. And so if you go to our website, you'll see this video of him out there, and it's literally him just taking nodes, putting them in the rack. And what happens behind the scenes is you've got to initialize the cluster. So what are the steps that you normally have to do with that? Well, Usually you have to send a truck, you've got to have IT resources, you got to plug in keyboard, monitor, type in IP addresses. There's all sorts of room for error and mistakes along the way. And what zero touch provisioning for us does allows you to automate that. So you can stage it ahead of time. All John had to do, my son had to do in this was just plug in the power, plug in networking. It reaches out to Fleet Manager, receives its configuration file, and stands itself up. So, talk about automation and simplifying deployment, that it really all comes down to making sure that you have the tools in place to stand something up quickly and easily, and that's what we do. Next on the node lifecycle, or the infrastructure lifecycle timeline here, is our day one operation. So it's okay, I've got my infrastructure stood up. I just had John install the infrastructure. How do I get my applications on it? And I'll walk through the UI. It's pretty simple to see, as you go through and add new VMs through the UI, using the REST API, maybe using Cloud Init to define, user data, metadata, pull down a container, that sort of thing. And then we also have integrations with common infrastructure as code tools. So if you haven't had a chance to go out and play with Ansible or play with Terraform, these are really, really powerful tools that allow you to interact with infrastructure as code. And on the, I will say on the Ansible, we've had this in place for a couple of years now, where it's a fully Red Hat certified Ansible collection that allows you to effectively consume the REST API that we have in an idempotent way. Terraform is coming actually in the March timeframe, so you'll see an announcement around that, but very similar, where it's the kind of the VM lifecycle of being able to stand something up. So if you've got several sites of this, it may make sense to automate that in such a way that you can basically just stamp out every new site as it comes. It looks like I had a question in here on, can I install Scale on my own hardware? And the answer is yes, actually. So we have just in the last year or so started to adopt a lot of new stances on this. So those of you that recognize this in the industry, we've almost entirely shipped as an appliance, right? So we take our software, we certify hardware and say, this is a known good solution with these guarantees around how things should operate. And I think what we found over the years is there are really a couple components that we really, really care about, and all the others just kind of work. And as a result, we're starting to loosen the restrictions around where we can make use of that. The first starting point of that is basically what we call an experimental installer that allows you to run on your own hardware for non-production workloads, right? So if it's in your lab, or if you're kind of a partner that wants to be able to stand this up to get some familiarity with it for demonstration purposes, or maybe a proof of concept, we can handle all that. And then we have kind of a layer in between this, which is more of a validated build, where we can say, this is known good hardware, fully supported in production. We can provide the software for that, and we meet in channel very commonly around that, especially on larger enterprise opportunities where customers have an affiliation with a specific brand or have some kind of buying power with one of the larger OEMs out there. We can say, yeah, we'll just provide the software and make sure that runs as you'd expect. Great question. So kind of continuing down the life cycle here, we get to day two, which again, I think this is where my brain goes when I think of automation. It's like, how do I make sure that things continue to operate once they're set up and running? And this is where a lot of the pains, I think, of IT management come in, is dealing with the day two operations once things are up and running, especially in a smaller environment. It's pretty easy to get something stood up and deployed, but once it's out there, it's the care and feeding that really takes all the time. So there are a few technologies that we've included in this that I'll focus on, really a couple of them on the hypercore side to just show off what I'm talking about here. But this is the concept is you want to be able to set this up and forget about it. You really want the infrastructure to care and feed for itself, so you don't have to actively manage and monitor it the entire time, and just know that it just, quote, works. And so if you look at the reviews that out there for the thousands of customers that we have, you'll see that as a very common theme. The other common theme I think that we're seeing in the market right now is that, in fact, I was looking through some of the slides of the other presenters here today, and I think several of them were titled "Do More with Less." I mean, that's basically what's happening right now, right? There's this general request that is, hey, I recognize that you're at max, but I need you to do more with less resources to be able to make that happen. And then we're seeing a further constraint now with kind of as Rick said, the hypervisor shenanigans. That is kind of forcing budgets to be put elsewhere, which means you're going to have to basically make do with the rest of that. So a lot of complexity that comes along with infrastructure in general. Troubleshooting is tough. things fail. It is hardware, and the further you get out on the what I call the edge computing spectrum, the further you get out to the edge of the network, the more likely it is that this is in a hostile environment and not in tier one data center with air conditioning, great power, and all the things you would expect out of a tier one. And so as a result, you need a solution that can kind of manage itself. So let me introduce a demo here, and I'll try not to bore you too long here with the our user interface and just use it as an example. But you're going to see me log into Fleet Manager. Again, that's the cloud-based orchestration tool, and then you're going to see me go into HyperCore, which is the on-premises HCI stack that we have at Scale Computing. So let me share my screen here. Perfect. Right. So here I am in Fleet Manager. So I've gone to fleet.scalecomputing.com. I've logged in. I see, in a single spot, day two is all about monitoring. And of course, you can kind of see a dashboard here. This is my entire fleet of clusters. I've got 38 out there, all in kind of different varying arrays of conditions going on across here, some critical, some warning. And I can really dig into that as I need to address these issues, but it's actually not what I'm going to focus on here. What I'm going to do is go into a single cluster that I have sitting near me. So this is my HE150 cluster. So one of the things, there are two technologies that I really want to highlight here. One is what we call AIM. It's Automated Infrastructure Management Engine. The other is called Scribe. Scribe is the storage layer. The AIM layer is the orchestration layer. AIM and Scribe work in tandem, and they both have different benefits. Scribe has the benefit of being, it's effectively, we created this storage layer to be consumed by the KVM-based hypervisor that we include in the product. And as a result, we can go on really, really small form factors like this Intel NUC that you see sitting behind me. This is actually what I'm running in my lab here that I call the HE150. That's our branded appliance that's based on the NUC, the Asus NUC today. And on this, I've got a handful of workloads that are running. I've got 3 nodes, each is a single drive, single CPU, a handful of cores. I've already set all this up in day 0, day 1 operations. When I get to day 2, that's really where AIM takes over, the orchestration layer. And so what I thought I'd highlight here in AIM is some of those day 2 scenarios that can happen, right? So I've got a workload that's running every node in the cluster. Okay, what happens if there's a failure? How is that handled? How do I deal with that? So what you see me doing here is actually reaching over. I've got this cluster sitting next to me, and I pulled out one of the nodes. So simulated failure, I unplugged the power. What you're going to see here is the AIM orchestration layer. The way this works effectively is that we have, actually, let me see if I can split screen here. So what you'll see here is on every single node in the cluster, each of these represent as a node, you'll see that we have collectors that are looking at bits of data. We're trying to determine what is actually happening in this. And then we're modeling reality based on what we think is happening with all this information we're collecting. And then we're only able to do that if we actually check that these values are within a range we care about. If they fall outside of a range we think is real, we won't rely on that data to make intelligent decisions. The conditions that you're going to start to see surfacing here are really considered undesirable. These are things where monitoring these collectors, we're checking all these values. We've got this hierarchical finite state machine. You can think of it as AI ops just built into the box to automate this for you so you don't actually have to do this yourself. And it's monitoring all these things so they can make intelligent decisions. The very first thing you're going to see is, the Scribe storage layer. We stripe and mirror data across all of the nodes in the cluster. If we don't have access to both blocks of data, you'll start to see this condition: data redundancy is degraded. The very next condition you're going to see is I've lost communication with the backplane. And one of the nice things about the state machines is that you can say, well, this isn't just a binary on off, I can't communicate. Oh, now I can. We can actually have a time lag associated with, we can say, if it's within this period of time, in this case, a minute or so, if we say, hey, we haven't been able to communicate for this long, now we're entering a new section of the state machine and can surface conditions related to that. So the very next condition you're going to see surface is I can no longer communicate with the node down or unreachable on the LAN side, right? So these warnings, it's really important that number one, the state machine technology is managing all of this. I don't necessarily have to. Once it finds that it's in an undesirable state, it's going to try on its own, without me having as the administrator to get on here to do anything, is to basically try to heal itself. So in this case, it doesn't have access to that data. The VM that was online here the set desired level of what we wanted for that VM was on, it is going to try to find additional space somewhere else in this environment to restart that VM. So it automatically restarts on your behalf. That's just an example. There are all sorts of other things that these conditions are monitoring, and kind of what it is that we're doing and enabling automation without you having to get on here and have to have a separate AOps tool to do this for you. We just handle this out of the box for our customers. So that's AIM. And we kind of already talked about the scribe storage layer there. Let me stop sharing here. I'll go back to my slides. And there are all sorts of other technologies in here that really kind of highlight what it is that we do. The two main ones, as I said, are AIM and scribe. These are hypercore functions that are just innate to that, to where you don't necessarily have to do that. And as you're faced with these very tough decisions that you have to make that would kind of be enforced on the industry right now, look for ways to optimize your environment so that you don't necessarily have to deal with the day-to-day care and feeding for the infrastructure. That's really what we do at Scale Computing. Some of the other things that you saw me log into Fleet Manager, centralized place to be able to monitor all of this stuff. That's great for day two operations. It has a full Fleet Manager API that goes along with that. And so with that, you can automate having those conditions that I showed here in Hypercore. All of that propagates up to Fleet Manager. And from a centralized spot, you can have that kick off support tickets. You can have that, kind of work into the workflows that you already have in place. If you're using ServiceNow, if you're using your own homegrown help desk, it can kind of kick off those processes on your behalf. The other thing that I didn't really highlight it, but as I was going into that Hypercore cluster, yes, it is sitting next to me, but I didn't actually go to the local IP. I was using what we call secure link. So without having a wide area network, I was able to actually get onto the nodes itself, into the UI, using what we call secure link, which is kind of a secure connection through a proxy service that we offer that gives me access to that local UI without having to set up a separate VPN or kind of managing remote desktops. All sorts of other things, but let me just share this last piece here, which is we do have thousands of really happy customers out there, and I would invite you to go out and find them and talk to them and kind of get their feedback directly on this. All sorts of reviews out there that highlight it. This is one of my favorites, though. This is Kingston Police is a success story of ours where, very similar that they have a cluster on premises today. They're running their applications there. And that orchestration layer, the AI ops that's built in is kind of handling the day-to-day to the point of near the bottom, you'll see it's basically so easy to manage and foolproof that they have forgotten their password, which I believe is a joke, but based in reality, that's kind of when I say set it, forget it, that's really the goal here, is that you don't necessarily want to have to get in there on a daily basis to do things. All sorts of other resources on scalecomputing.com around that AIM layer, scribe, heat, fleet manager, a whole theory of operations that we can go into as well. But a lot of really great resources out there. And I would actually invite you to also watch the zero touch provisioning demonstration that my son had done. It's pretty hilarious to watch. So Mackenzie, with that, any questions that have come in that I can answer?
Absolutely. Let's dig into it. So, first question I've got in the queue. Someone's asking, can nodes be added and removed to an existing cluster with ZTP?
Yeah, great question. Yeah, so the whole concept I was talking about with zero touch provisioning of setting up the cluster itself, right? So you plug in power, plug in networking, it connects into Fleet Manager, receives its configuration file, sets itself up from beginning to end. That same process exists for node additions, node deletions, and kind of the whole life cycle of nodes over time. So, yep.
Perfect. I've also launched the poll there. So everyone, if you're looking for some additional information about Scale Computing's solution, well, again, this is your wish list, your easy button. If you're looking for anything specific, data sheets, white papers, demos, etc. So just thought I'd call that out. And okay, what next? What setup is required to run Fleet Manager or register nodes to it?
Oh, that's a really good question. So with Fleet Manager, there are a couple different methods to do this, but the one that most people use is we basically auto-register things for you. So if once a purchase order comes in, basically our process is image these, ship them directly to you, and we register that with your organization within Fleet Manager, so you don't actually have to go out there and add them yourself. So when you sign up for Fleet Manager, you're going to get a login that says, here, go here. Even at that point, you can log in, see the nodes, and even see that they're being shipped out to you and what date they were shipped.
Awesome. Great. Thanks for that. Mark is asking, how does scale computing's hyper-converged infrastructure compare to traditional virtualization and cloud solutions in terms of total cost of ownership, scalability, and ease of management?
Yeah, so hopefully the ease of management was covered as part of the demonstration. I mean, it really is a set it up and don't have to worry about it anymore. I will say scalability wise, one of the nice things about the way we architect the system, and it's a little punny in that scale is our name, but you can really mix and match a lot of node types together, different generations of CPU, different mixtures of storage heavy nodes, RAM heavy nodes. So basically, as your environment changes over time, we expect that you can just add another node, and the whole system scales out based on that. And again, we also support storage only mode, right? So if you just have storage needs that you're expanding out just the storage, and you don't need the extra computer, don't want to pay for Microsoft licensing, which is a common thing that we'll hear, you can do that. So a lot of flexibility there. And then the last one's total cost of ownership. There are kind of four pillars to scale computing. It's basically availability, scalability, simplicity, and the last one is almost always cost. So our total cost of ownership is one of the lowest you're going to find in the HCI space, and it does compete really well against traditional virtualization and cloud solutions as a result of that. And actually, just this month, we've introduced some new pricing that I'm very excited about, like full on a package of all you can eat with 3 nodes at a very, very affordable price point to fill the gap that has been left behind by hypervisor shenanigans. I'm stealing that term if you can't tell. It's one of my new favorites.
Hey, I like that. Hypervisor and all you can eat with 3 nodes. I'm in for it.
Yeah.
Okay. Okay, we've got one here. Can I install Scale on my own hardware?
Yeah, this was asked in chat as well. And the answer is yes. We've got a few different ways we can do that. And depending on what the needs are of production versus non-production, we've got different solutions for that. So just work with the team and we can provide you what you need.
Okay, sweet. Edward's asking, how does Scale Computing's SC/Hypercore platform specifically help IT teams with limited resources streamline their operations and reduce overhead, especially in distributed or edge environments?
I honestly, if I didn't know this wasn't seeded, I would have said, this is the seeded question. This is where scale computing shines. It's
Thanks.
everything we do within the product. Yeah, everything we do within the product is really designed around minimizing the need to ever have to interact with the infrastructure. So in a small, medium-sized organization where you have a single person that's in charge of everything from answering the phone with help desk to managing the infrastructure, it means that's less time they have to spend with care and feeding the infrastructure. It's just going to work. I can focus on other things. In a distributed environment, that's just, it basically is exponential because there is no IT resource on premises, right? So every decision we make is, how do we avoid having to roll a truck out to a site to deal with a failure? It's one of the reasons we support these small form factors. It's really nice to know, hey, it's kind of the whole cattle versus pet mentality. If something fails, you shoot it, you replace it. And so that's how we work in a distributed environment, and a lot of success there.
Awesome. We have a couple more minutes. We had a couple of questions about the AIM that you brought up during the presentation. So first one is, how does AIM's AI-driven automation enhance efficiency of managing IT infrastructure compared to kind of more traditional management methods? And then I'll have a follow-up for you.
Yeah, so the AIM orchestration layer literally is like having an IT administrator in the box. It is constantly looking at what the current reality is, what the desired state of that environment is, and then if it's not in that desired state, it's going to take a very same path to get as close as it possibly can to that desired state. So a whole lot of words to mean you don't have to worry about it anymore. And so comparing that to a traditional environment, there really is no concept of AI ops built in as a feature in a traditional environment. It's usually a third-party add-on thing that may or may not fall short of what needs to happen. This is very bespoke. It's very integrated into the product where you don't even have to think about it.
Awesome. And then someone was asking about with AIM the predictive analytics, and if you could provide some examples about how that works. How does it help prevent potential system failure?
Yeah. So if I understand the question right, there are three different layers to AIM. There's the collectors layer where it's kind of just collecting data, temperature of the drive, current this, all the things, right? The next layer up is basically saying, does the temperature of the drive fall within a range that I can rely on? Like, is it reporting back 2 million degrees Kelvin or something that is clearly not something I should rely on as making a decision? If it is within a range that we think is reliable, we will then have that inform the next layer up, which is kind of where conditions are set using state machines and monitoring all that. So some examples are drive fails. We're going to recognize we can no longer communicate with that drive. We will automatically restripe, remirror the data that was on that drive elsewhere in the cluster. That's a really common failure. If it's a full node failure, like I just demonstrated here, it's going to verify several things before restarting those workloads somewhere else in the system. Predictively, though, if we start to see, MCEs and things like that, where you can almost predict that hardware is failing, we can take corrective action and migrate workloads off. We kind of have it within our control to build in the intelligence we need within the solution based on our years of having things like this in the environment, kind of out in the IT environment.
Fantastic. Well, we are at time, but I want to just give you a final chance to, you've got some resources up here, but anything you want to shout out, any sort of, next steps if someone is really keen on taking a dive or taking,
Yeah.
Go ahead.
No, I appreciate you setting me up. So yes, these resources are great. Go to Scale Computing. There's a whole bunch of stuff there. I would say there are two things that I would invite you to look at. Number one is check out what other customers that are just like you are doing in this and what their response is to running this. And there are all sorts of review sites you can go to look at that, Gartner and G2 and all sorts of them. The other is we actually just launched a new pricing tool online where you can go through and it's not going to be exact, but it's going to give you a really good approximation of kind of the cost of a solution like ours. And of course, that's, as I said, it won't be exact. So you're going to want to engage and make sure that it is right sized for what it is you need in your environment. But those are really two good resources that I think a lot of people should look at if you're interested.
Awesome. Well, thank you so much. Much appreciated. I'm glad we got time to cover a good chunk of those questions. And until next time, Craig.
Thank you very much. Good to see you all.
You too. Pleasure.